This meeting is being recorded.
Okay, just waiting maybe like 1 or 2 more minutes for some more attendees to join, and then we will start. Okay, so I guess we'll start. Yeah, dear all, a warm welcome to everyone from the Israel Economic and Trade Mission in Berlin. We are very happy to have a great audience today from Germany and from Israel, but also from other countries. My name is Jonathan Matalon. I work as a trade officer here, where I'm responsible for the space and aerospace sectors, among others. Before we get started with today's not only exciting, but also highly relevant topic, I will shortly introduce our office as well as our partners. The Israel Economic and Trade Mission is the outer branch of the Israeli Ministry of Economy and Industry in Jerusalem. We are part of a worldwide network consisting of 45 trade missions, helping Israeli companies enter the local markets and spread the word of Israeli innovation across all sectors. We also offer to scout for Israeli innovation for any German company interested and deliver the service for free as we are a publicly funded institution. Please feel free to approach us at any time and we will help you to get access to the Israeli innovation. With some of you in the audience, we are in continuous discussion and we are very happy about that. But before introducing today's agenda, let me thank our partners. First of all, to Esther Elias, the head of the Economic and Trade Mission to Berlin. And of course, to our dear colleagues from the Israel Export Institute, namely Tal Simantov and Nofar Movedian. It's always a pleasure to work with you. A big thank you as well to our keynote speaker from Israel, Tal Inbar. So what can you expect in the next approximately 1.5 hours? We will start off with our keynote by Tal Inbar. Tal is an independent researcher on space policy, and he follows the Israeli space industry since more than 3 decades and is also part of the Missile Defense Advocacy Alliance. He will introduce the Israeli space ecosystem and give an overview of the Israeli innovation in the space sector. Then we're going into the second part of the session, the company presentations. First of all, we will give the floor to Nadav Nachshon, the co-founder and CEO of Gorilla Link. Secondly, we will listen to David Bergenboin, Director Business Development at Cielo. Thirdly, we will hear a presentation by Meir Moalem, the CEO of Sky and Space. And last but not least, we will give the stage to Mark Goldfarb, CEO and co-founder at Sixtov Space. After the presentation, we will have time for some questions. And after the event, we will be more than happy to engage and initiate follow-up talks and connect you to the companies. Please don't hesitate with feedback after the event. We are always happy to connect. All the companies' presentations will be provided in a follow-up email, and as Esther mentioned before, the recording will also be shared after the session. It's now my pleasure to give the floor to Tal Inbar. Tal, it's a pleasure to have you. The floor is yours.
Okay, first of all, thank you. I hope that you can see my presentation. Okay, so first I'm very happy to address you all, my colleagues from Israel and of course European friends. Just to speak briefly about Israeli space, innovation, cooperation, international collaboration, and more, we will need a 2 days event at least. So I'll be very much brief about some major trends regarding Israeli space. And I start with a very, very condensed and short history of Israel in space with only one slide. First, the motivation to embark on a national space mission or a space industry and so on was the negotiation with Egypt and the peace accords that was signed in 1979. And Israel wanted a way to see what's going on over the Sinai Peninsula, which we evacuated after the peace accord was signed. So the idea was to build a national reconnaissance satellite. And in 1981, the Space Directorate at the Ministry of Defense was founded, followed by an Israeli space agency, a civilian organ, designed and envisioned to embrace the international cooperation with other countries in 1983. Back in 1988, we launched our first satellite, which was just a technology demonstrator using an Israeli developed and, of course, operated also from Israel. So we have also a launch capability for our satellites, at least part of them. Then in 1995, the first operational reconnaissance satellite, Optic 3, was launched successfully. And we had an astronaut in 2003. Unfortunately, it ended up with the Columbia disaster. And this is just several steps in the history of our first, our national space program. I can divide the program into governmental space and entrepreneurial space, and you will hear some representatives from the entrepreneurial space after my short presentation. So I don't want to take from their time, but without the governmental sector operated for more than 30 years, we wouldn't have any entrepreneurial space today. And the current situation is that a cooperation between the government and the private sector in space is not only possible, it's mandatory for the success of Israeli space. And this is the case, in my belief, not only in Israel. So I mentioned that we have launching capability since 1988. And we can launch satellites from Israel, and we are in a peculiar situation in which we are launching toward the West. So from day one, it was understood by Israeli engineers that our satellites must be small, compact, lightweight, because of the restrictions of launching to the wrong direction. Because we have some geographical limitations if we want to launch to the east. And part of our satellites are launched outside Israel by commercial launch vehicles like the European Ariane or Vega launchers. And in Israel, it was decided back in 1984 that IAI, Israeli Aerospace Industries, will be the core factory and manufacturer of our satellites and also the launch vehicle. And from day one, they constructed a lot of remote sensing satellites. You can see some of them here, and the upper right, this is a remote satellite, remote sensing satellite built for Italy and launched in 2017. And on the left side, upper left, you can see our latest generation remote sensing for the Ministry of Defense.
Al, apologies for interrupting you, but
sure.
You're not on presentation mode, so we just see the first slide. So if you can just put it on presentation mode so everybody can see what actually you're talking about.
I'm trying to do it. I shared my screen and
see now we see the third slide, but we don't see, as you're speaking and changing slides, we don't see it.
I'll try to share it once more.
Interrupting you. Now we can see, thank you.
Okay, so this was the short history about some points in the development of Israeli space. And like I said, the switch was made from governmental space to entrepreneurial space, and the cooperation between the two sectors is mandatory. This is our Shavit, Hebrew for comet, launch vehicle that we are launching to the west. And you can see several of the remote sensing built by IAI during the years. And the current generations are on the left and the right, upper right. And other companies like Imatsat International, which was founded by IAI and some partners from the business sector years ago, is now one of the leading companies here to sell images from space, but not only the images, but also analytical analytics of the images. And they are now embarking on a new space program, developing their own remote sensing satellites. So from services, several companies are now going into a new direction of building a space capability from components to a complete system and solution in space. IAI also built a radar satellite, and of course, we have the advantage to see not only during daylight, but during night, and the fog and the clouds are not obstacle anymore. And there is an interesting cooperation based upon the governmental investment in the Ministry of Defense space arena years ago. And this is the Venus satellite, remote sensing satellite for environmental purposes, water research, and agriculture. And this is a joint Israeli-French space program. And actually, the satellite itself is 100% Israeli because France was supposed to build the camera. At the end, they gave us the camera, but they bought it here in Israel. So it's, again, complete Israeli-made satellite. And of course, we are also operated in the geosynchronous orbit regime with IAI capabilities to build ever-growing and more sophisticated communication satellites for various purposes. Elbit bought years ago ELOP, electro-optics company, so now it's Elbit Space. They are building our telescopes for the remote sensing satellites, but also for the next generation ultraviolet space explorer. You can see it on the right, which is Weizmann Institute of Science project together with NASA. And the name for this satellite will be Ultrasat. And now Elbit, from a provider and manufacturer of just components, is also involved in the new and independent space program. And you can see the first generation of very small nanosatellite by Elbit. We also have a lot of companies dealing with every aspect of space that you can imagine. For example, Akhtar is a company in Israel which created the blackest black that you can imagine. This is a color that you can paint the inside of satellites, telescopes, and so on. And you can see just some of the users of this unique paint. And Ramon Space, used to be Ramon Chips, is responsible for designing and building processors for space missions. And you can find Ramon's chips inside the various spacecrafts, not only around the Earth, but also in the Japanese probe to an asteroid, and many more space missions to go. We have a capability in Israel to create a very sophisticated, efficient, and reliable space propulsion. And this is made by Rafael, which is responsible for the third stage of the Israeli launch vehicle and also for the propulsions for all the Israeli spacecraft since the beginning. And you can see on the upper left, the propulsion unit for the Venus satellite, which is a dual mode propulsion, hydrogen and electrical propulsion. And below you can see for one of the Optic satellites. And speaking about electric propulsion, this is a very interesting area to explore. And we have a proof of concept of several of those thrusters already operated in space for several years in the Venus satellite, for example. New Rocket, this is another startup company in Israel, is involving with new propulsion modes, gel propellants. So you'll probably hear about it in the future. And Rafael, from a provider of propulsion systems, is also now embarking on a very interesting plan to build a variety of remote sensing satellite, optical, and SAR as well. And we have governmental space, we have entrepreneurial space, but we also have a very vibrant scene of educational space. And you can see just several samples of satellites from the Technion, satellites that are built for the Ben-Gurion University in the Negev, and some satellites built by high school students. And we have several of them operated in space as we speak. We are also part of the global space arena. Just recently in January, we signed the Artemis Accords with NASA and other space-faring nations. So we will play a role in the future lunar exploration. In that regard, I can mention Stemrad, which is another Israeli company that built and tested in space already a radiation vest for the protection of astronauts for long duration. And NASA declared that this will be an integral part of the equipment that astronauts will take to the moon in the Artemis missions. Another company, Terra, is now exploring how to protect Earth from wildfires in the forest using an array of small satellites in space. And we went to the moon in 2019 by the Bereshit spacecraft. Actually, we landed on the moon, but not in the nominal velocity needed to a soft landing. But nevertheless, it was a cooperation between private enterprise and IAI and other Israeli companies with some support from the Israeli Space Agency. And not many countries can say that they sent a probe to the moon. Speaking about the moon, another Israeli company named Helios is now exploring the possibilities of producing oxygen from the lunar regolith. And this is another example of Israeli innovation in space that will provide, hopefully, in the future, much more convenient conditions to astronauts on the moon. Space Pharma is another Israeli company which is responsible for providing researchers with the means to conduct very sophisticated experiments in microgravity environments, either on the International Space Station with a small laboratory or by an independent free-flying satellite. And several of those satellites and experiments were already conducted in space with a very good rate of success for all the researchers. We are also part of the in-orbit services now under Astroscale Israel, which is of course a subsidiary of Astroscale. This is a drone, a space drone, if you will, that can be attached to another satellite, drag it, extend the life, and in future perhaps to help make the space around the Earth cleaner, and to remove space debris and so on. Another company is now giving services to analyze the infrastructure of large cities, water leaks and so on. So this is another application of the capabilities of remote sensing from space, not just for military applications. NSL.com is a small Israeli company which is building a very interesting antenna high gain antenna, but with small dimensions, and it is folded during the launch, and it will give very small satellites the capacity of much larger satellites in terms of megabytes per second for every application that you can think about. And just recently, we had a very interesting conference last week about Israel space innovation. There is another startup from Israel, which is now working on a hybrid propulsion launch vehicle, very small launch vehicle that could be launched from aircraft or from a ship at sea with a reusable mode. So it will be much interesting to see in the years to come our access to space solutions, not only based on the heritage capabilities that we have from the National Space Program. So I would very much like to speak about the innovations of tomorrow, but I don't know what they will be. So in a future event, I believe that you all can hear a lot more about new companies, new ideas from the minds of Israeli entrepreneurs. And I can say without a doubt that we are now in Israel very much open for business, cooperation, international collaboration, and you can hear those words and much more from the representatives of any other space companies represented here in the webinar today. And if you have any questions after the event, you can use one of the communication ways that you can see on the screen. And again, I thank the organizers for the opportunity to speak, and very best of luck for the Israeli space.
Thanks a lot for this insightful presentation. We're now a couple of minutes early, 3 minutes, but I hope this doesn't make a difference for all of you. So next, I would like to ask Nadav Nachshon from Gorilla Link to the stage to hear about their products. Nadav, the floor is yours.
Hi, everyone. Very nice to meet you. It's a great opportunity to present here to the Israeli trade mission to Germany. I will share the presentation. Any questions that you might have, please feel free to contact me directly. So, as you probably know, a lot of places on Earth don't have a stable connectivity. These places mostly not populated by civilian, it's not our cities. It's more the agriculture, the oil and gas, the water treatment areas. So huge areas. In Israel, we don't really familiar with this type of problems, of connectivity problems. But all over the world, we have these issues. On the other hand, we see 1 million IoT devices almost every day added to the market. So basically, we see a transform of getting data out of sensors and presenting this data and getting insights from this data. So this data is the way we can make our food more accessible, our power more efficient. And what we see basically is, what we say is that 80% of the land of the Earth is not covered by any type of communication. I'm not talking about the oceans, only the land of the Earth. In order to deploy IoT sensor it's not more, it doesn't call anymore IoT, right? It's not connected to the internet. It's a problem. You cannot deploy these sensors in locations where you don't have connectivity. So 80% of the potential market for these IoT sensors is not covered. So what we say is it's bad for businesses that try to get this data, but it's also worse for humanity. So humanity can get a lot of data and make life on Earth much better. Today, in order to get this data from remote location where you don't have connectivity, you don't have Wi-Fi or cellular, you basically need some way to transmit it. So you can use drones, you can use expensive satellite communication solutions, or you can also send personnel, like employees, to take the data out of devices manually. But all of these solutions are expensive and inefficient. So what Gorilla Link says is there is a new technology in the market. There is the new satellite networks, the new space IoT satellite networks. Those networks basically have global presence and can connect sensors to the internet. So me and my brother, I'm the satellite IoT in the last 10 years, and I'm a cloud architect of both AWS and GCP. And my brother is electrical engineer, worked for extensive soldier-to-soldier communication product in the army. So both of us created a solution in order to connect sensors to the internet seamlessly, harnessing the satellite IoT networks. So what basically we want to do is we want any sensor to connect seamlessly to the internet using these satellite networks globally, operated globally, even in location where you don't have cellular or Wi-Fi. And a most important thing is to make it very cost-effective and seamless. We are now connected to several satellite networks. We are backed by the Israeli Space Agency, the Israeli Innovation Authority, and also by space investors. So our solution is an end-to-end solution, and Gorilla Link is basically saying that using Gorilla Link, any web developer is a space engineer. So you don't need to have any experience in the space or to know how to communicate with satellites. While using Gorilla Link, you are covered. The IoT market is huge. Only by 2023, there are going to be 3.5 billion IoT devices connected to cellular. This is not including the devices connected to Wi-Fi, etc. The number of satellites going to be, the estimation is saying that we're going to be around 100,000 satellites by 2030. Today, we have a few thousands of satellites. So this market is growing in an amazing way. And we think, as the head of the Israeli Space Agency said, that space today is like the internet in the 90s. So this is the time to start looking at the space solution, because everything is changing there, and it's an amazing opportunity. If we are looking at the agriculture, only looking at the agriculture opportunity is $16 billion, sensors deployed for those applications. So this is just a short video. And basically what we are saying is that with Gorilla Link, any sensor can be deployed anywhere on the globe, and the experience needed to do it is very minimal. And we are here to connect as many devices as possible to space and use this amazing growth in the space industry. Thank you very much for your time, and looking forward to connecting with you later on. That's it. Thank you.
Okay, thanks a lot, Nadav, for this great presentation. Next up, we are going to listen to a presentation by David Bergenboin, Director Business Development at Cielo. David, the floor is yours.
Thank you. All right. You can see the presentation?
Not yet. Yeah, there it is.
All right. So thank you very much for the opportunity to participate at this exciting event. So I will start. My name is David. I'm a Director of Business Development at Cielo. Cielo is a small company based in Jerusalem. And in the past 7 years, we are working on the space industry. We are already employed several units to the space in several occasions, and at least two satellites, Israeli satellites, that was sent at Optic 11 and Optic 16. Until now, we not needed to send any technician to space to have any repair activities.
David, sorry to interrupt you, but could you switch to the presentation mode so everybody can see it more effectively?
Much better?
Yeah, that's better. Thanks.
Okay, so our company makes various of navigations and sensors on inertial solutions. We are working on fiber optic gyroscopes. I will elaborate about it later on. Our space systems, basically, we have two models. One is the Starlight 1000. This is, you can see it right here. This unit is a very extremely high performance with accuracy of 1000 degrees per hour. It's of course space qualified, and as I mentioned, we have already the heritage in space, and we have several additional production for the next missions that the Israeli government and additional governments abroad. The other unit, the smallest one, in the right, you can see right here, it's a Starlight 10. As we are getting into the new space area, we understood that the cost and the size is matter, but it's impossible to send any regular electronics modules to the space and to assure that they will still work. So with our heritage and experience on the space modules, we started to develop this unit. It's still in the stage of design, but we know that with our experience, it's a niche solution that can provide for small and medium satellites and payloads the right approach for them, for what they need for their requirements. If I'm getting a little bit about our technology, gyroscopes, there are various of technologies. One of the technology is a closed loop fiber optic gyro. As we are a tech company, we own the technology and we are all in-house, meaning design and manufacturing, everything here in Jerusalem. So from the IOC and the fog chip and the ability to the sense of the light, everything and the coils, everything is based in our infrastructure here in Jerusalem. If anybody has some questions, please don't hesitate later on, of course. The idea of fiber optic gyros is that there is no any moving parts. If you design the electronics as needed, the MTBF mean time before failure will be very high, and it will be qualified for a lot of hours of operational hours. In addition, there is no any required maintenance activity. And of course, the idea is as much as the coil will be, the length of the coil will be higher, so the accuracy will be much higher. And we are able to scalate as much as needed for the requirement of the customers. And by that, we are telling solution easily. So as I'm approached to the small module, so this module is a niche, as we are knowing, as we found that there is no more companies today that are able to provide this kind of solution for space application. So it's a small, I can show you right here. This is the model itself, right? It should be somewhere between 1.1 till 1.3 kg. Is of course space qualified, and the accuracy is in between 0.5 till 10th of degree per hour. It can be as a IRU, initial reference unit, without accelerometers, or it can be as IMU, initial measurement unit, including accelerometers that qualified for space. So we spoke about space activity, but just to give you a snapshot about our company. So you can say that over the years we had an approach to all the terrain, meaning air, land, marine, and space. In the inner circle, you can see our family line. From the IMU family that you can see right here, till tailoring solution for several customers in different cases and volumes, till INS, initial navigation solutions that we are providing with the ability to embed various of GPSs or various of sensors, node finding, and of course, space products. In the outer circle, you can see the platforms that we already have been working with them. So from launches, UAV, aircrafts, missiles, munitions, payloads, whatsoever, and we are more than happy to find a partner for produce the Starlight 10 that I mentioned right here on the electronic side. And from the other side, we're also looking for a partner that can invest to promote this unit go to market. That's it. Thank you for the opportunity and have a good day.
Okay, thanks a lot, David. This was very insightful. Next up, we're going to listen to Meir Moalem. He's the CEO at Sky and Space. Meir, we're looking forward to your presentation.
Yes, thank you very much. Just can you see my my presentation now?
Yes, but
Okay, I'll just switch to presentation mode.
Yes, thank you.
Okay, great. Thank you very much for the opportunity to be here and tell you a bit on Sky and Space. Actually, my work has been made a lot easier following the presentation by Gorilla Link. So that shaved a minute or two from my presentation.
For this great presentation. Next up, we're going to listen to a presentation by David.
I'm hearing a recording in the background for some reason.
David, the floor is yours.
Am I the only one who's hearing that recording?
All right.
There was a recording in the background.
Okay. Well, let's see how it goes. All right. So Sky and Space is a company that was established almost 7 years ago, back in 2015. It's a UK company with a subsidiary here in Israel and a holding company based in Australia. Over the course of these 6 years, we have raised something close to $60 million US. We have launched 3 satellites in 2017. We have demonstrated for the first time in the world the ability to conduct inter-satellite communication using nanosatellites, roughly 3 kilograms in size, in mass, and about this size, half a shoebox. And we were able to demonstrate also the ability to perform store and forward IoT message transfer, and above all, doing a phone call in real time using a network of nanosatellites. What we're trying to achieve is to deploy a network of satellites in space, creating like a mesh of routers connected to each other, providing global real-time connectivity, initially for IoT purposes, what we used to call machine-to-machine, and later on the ability to provide real-time services such as instant messaging and, of course, doing phone calls as well. So let's try to move forward here. Here's a description of what we're doing. So that's basically, you're very well familiar with these solutions. You have a whole bunch of satellites flying overhead. When they pass over a ground terminal or a ground station, they can pick up the information, store it, forward it, and download it when they pass over the next ground station. That's nothing new. A lot of people do that. It's actually very easy to do. We've been doing it in Israel, by the way, through high school students back in 2016 with the nanosatellite called the Duchifat-1, which is 800 grams. So there's no real challenge in doing store and forward of information using a nanosatellite. Well, we've taken that to the next level with 2 components. One of them is what we call a micro gateway. Each one of our ground terminals, which are, by the way, very small in size, about this big, can actually operate as a full capabilities gateway. So just imagine below the satellite, there's a footprint of, let's say, 1,000 kilometer diameter. And in that footprint, you would have 500, 1,000, 10,000 ground devices trying to connect to the world. Even if one of the ground devices can be connected to the internet, immediately we've created what we call a micro gateway that connects everybody under the same footprint to the rest of the world. That's the first component, which is quite unique. We're the only ones who've developed this kind of technology. The other piece is what we've proven in space back in 2017, and this is the inter-satellite connectivity. Once we deploy a critical mass of satellites with inter-satellite capability on board them, actually we've created a network space. You're seeing one satellite, you're seeing the entire network, and you're always connected. And that way we can connect anyone, anywhere, anytime that we want. So, by the way, this presentation would be available to anyone who would like to receive a copy of it. That's why I'm going through that relatively quickly. So the company has the industry expertise, the first mover advantage. We have developed, in order to be able to succeed in our mission, we had to develop our own network management software. And we had to be extremely efficient in the data transfer. So we have developed unmatched data compression algorithms and capabilities which far surpass what you see today by the leading commercial algorithms and protocols. So we can squeeze more juice out of our satellites and out of our network. One of the biggest problems for entering the field of providing satellite communication is spectrum rights, the ability to use certain frequencies in order to provide commercial service. We have not only registered those spectrum rights in the S-band, we've already secured them by bringing into use the frequencies that we have. We have registered over 140 megahertz. We're only using about 10. So there's an incredible growth capability in the system. But that's not enough. I mean, you could have the greatest technology and the best spectrum rights. If you do not have the ability to transform that into commercial agreements, then there's nothing to do with it. Well, we also have a long list of customers already signed in to use our services once they are available. And I'll tell you the schedule in a moment. The company, as I said, raised over $60 million. It was a publicly traded company at the Australian Stock Exchange with valuation of roughly $300 million. We've taken it out of the stock exchange and now it's a private company. Recently, we've raised $11 million. We've signed a contract for the production on the terminals and production of the satellites as well. And we're now in the stage of the preliminary design review for the satellites, which are expected to be launched by Q1, Q2 next year. So in less than a year from now. Just to show you that we have nice pictures of the people involved, and you can take a look at it later. Speaking a bit of our satellite, so this is the satellite that we have today in space, the 3 diamonds, 3 of them similar. By the way, we're operating them for 5 years now without any failures. We're maintaining formation flying in space without any propulsion for the first time ever in the world. And we're doing that again for almost 5 years. In 3 weeks, it will be 5 years. And controlling that formation constantly in space. The S-band frequency that I've talked about, the compression algorithm, but also a multi-channel modem. One of the biggest problems today to provide IoT services today from space is the ability to interact with multiple users on the ground. So utilizing the frequency resource that you have in the most efficient way. So this is also something that we're doing, very advanced modem that allows us to utilize our satellites and our payload in the most efficient and possible way. So the value proposition is there. If any one of you wants to invest in Sky and Space, you're more than welcome to give us a call. But seriously, it's a comprehensive, proven in space solution, which is cost effective, which is going to transform the way we treat narrowband satellite connectivity. And narrowband satellite connectivity has been around for many years. I mean, you can provide today Internet of Things from space anywhere across the globe. There's only one problem. You would have to pay an arm and a leg in order to do that. The existing companies such as Iridium or Inmarsat or Global Stars or these guys, they've invested millions, hundreds of millions, and even billions of dollars in order to deploy their space systems. What we're doing is using the innovation, the disruption, and the advanced technology of new space, using nanosatellites, and by that, reducing the required capital by 1 or 2 orders of magnitude. So just to give you an idea, if Iridium has built its system with $3.5 billion, if Global Star has signed a contract for $330 million for 17 satellites, we're doing a constellation of 50 satellites with less than $30 million. So it's a dramatic difference at the cost structure, which allows us to enter the market and offer these solutions. The business model is scalable, and just imagine it's like the same way that you're connecting your phone to your router at home and you're connected to the internet, you can connect to one of our satellites in the future once we have the critical mass, which is something like 100 satellites in space, and you're connected no matter where you are, in the middle of the ocean, in the middle of the outback in Australia, or doing a safari in Africa. Doesn't really matter. This is my last slide, just to propose some things that we can discuss and talk about for potential cooperation or collaboration. So advanced satellite communication is something that we're looking into, and we have some projects on that, and we're open to discuss additional ideas, advanced modem or advanced ground terminals. Direct to phone satellite technology, this is the future, and we're already thinking on that, how to implement that in order to cut down the kind of middleman, which is the satellite terminal, and just use your phone to connect to our system. Quantum encryption, this is the future in all connectivity and in satellite connectivity as well. Our system will be highly protected from cybersecurity aspects. We're one of the first commercial satellite companies who have demonstrated cybersecurity measures and tools in the system in a collaboration with Checkpoint, which is an Israeli mega cybersecurity giant. And we're looking into implementing quantum encryption and also quantum key distribution using our systems. Optical intersatellite communication, which removes the requirement for any spectrum filing or spectrum cooperation and coordination in space. And even a more far-reaching vision, which is creating networks for communication at the moon and Mars using our system, which is extremely efficient and can provide full coverage of the moon at an incredibly low cost. And there are other ideas which, for obvious reasons, I can't really talk about. So again, thank you for the opportunity. We welcome any of the attendees to contact us and to discuss any potential collaboration that you may think of. And that's it for me. Thank you very much.
Great. Thanks, Meir, for this interesting presentation. And last but not least, we're going to listen to Mark Goldfarb, the CEO and co-founder at Sixth of Space. Mark, the floor is yours.
Thank you. Thank you. Let me just share my screen. Is the screen sharing?
Yes.
Great. So thank you for having me here. I thank the Export Institute and the Trade Office, and I appreciate the opportunity of presenting Sixth Of's technology. We are doing tracking, and it's not limited to the space. It's limited to everything you have in the world. We have space applications. We have down-to-earth applications. We're low latency and no camera tracking. We're using lights for tracking. Our technology is high speed. It's private because we're not using cameras. It's accurate, low latency, low power. We're able to run our algorithms on as small as a Raspberry Pi computer. And because we're seeing the light at 1,000 times a second, and we're only seeing the lights, we're very low bandwidth. A little bit about the company. We're based in Jerusalem. I see that Jerusalem is overrepresented in this event, which I appreciate. We've been around since 2017. We're currently a team of 15 people. We have 4 issued patents already. We've been heavily supported by the Israel Innovation Authority. We're a 3-time recipient of their generous grants. And I think most relevant to this event is in 2020, we were finalists in the NASA iTech competition. A little bit about our technology. I'm not going to run through the whole, so I'm going to jump ahead a little bit for a second and then go back. What we're doing is we have optics that compresses the light. So any light that comes in alpha is being spread over the linear sensor. Any light that comes in beta is being brought to the same point. So the result being that if you have two of these optics on top of linear sensors, one in the X, one in the Y, we're able to convert at the optical level a 2D image of the lights of the room into a 1D image. And essentially what you're doing is summing up, if you have a 2D camera grid here, we're summing up the X and we're summing up the Y, and it's a tremendous reduction of data. Now let me jump back to where this is relevant to the applications. If we are started with headset applications, actually, if you look here in the training, when you move your head from side to side, up and down, the position is defined by 6 degrees of freedom. The X, Y, Z, and the roll your pitch. And hence, that's where our name comes from, 6 degrees of freedom. And that's how we started. What we realized, though, is that there are a lot of applications outside of AR and VR for our application. So we're currently working with Israel Aerospace on drone formation, collision avoidance. Using our technology with sensors and lights on both sides of the drone, we're able to get drones to be much closer together and to avoid collision. Our technology can be used for training, any type of, we're using virtual reality or augmented reality in training to get very precise and to reduce the nausea effect that a lot of the current training systems that are based on slower camera-based head tracking systems rely on. Autonomous navigation in tunnels or in any indoor space. We work both indoors and outdoors. It's really a factor of how bright the light is. So outdoors, and I'll show you some examples in a moment, the beacons are brighter. Indoors, they don't have to be as bright. We work with both infrared and visible lights, but almost all our customers to date have opted for the infrared to minimize interference. And then where NASA suggested us is landing, that they looked at our technology and said, if you put a beacon on the ground, we can handle the last 20 to 40 meters of landing for a spaceship or a drone. And that's a use case we're starting to explore. We recently went in heavy Israeli sunlight. We were able to track a drone at 40 meters up in the air to guide it down for a landing. And there's both very exciting aerospace and commercial applications there. In the commercial side, it can be drone-based deliveries. One of the other talks spoke about applications of satellites landing on moving targets, boats, and we could definitely be very instrumental in facilitating the landing where you have a moving beacon to do that. One of the tricks in our technology is we have, let me just jump over to this slide, sorry, is we have the beacons, we have the ability to pulsate them at a unique code. So we're not only seeing the light, which is what our native sensor does, it sees the relative movement between the lights, but by identifying which light by looking at its unique code, we also can localize to exactly where you were. So let's say there are 5 moving locations in a general area where you want to land a satellite, spaceship, drone. Each one will have a unique code. The sensor will know which code it's looking for, and when it gets down to the last 30, 40 meters, will guide itself into the correct landing. In terms of our sensors themselves, our current sensor is a 15 centimeter baseline, but our new version is dropping down to about a third of that size, half to a third to 3. That will be introduced over the next couple of months. As a company, we are starting to get more into the space, but we've done quite a few initial integration projects in industry, in robot tracking and forklift tracking in warehouses, AR, VR tracking for entertainment, and in large, big commercial areas such as theme parks. We've also done medical robotics, tracking the robotic arms in real life situations. So happy for any questions after this during the Q&A period, and I appreciate the time here. Thank you very much.
Thanks a lot, Mark. Now we have time for some questions from the audience. If you raise your hand, you can get permission to talk, or you can just pose your question straight into the chat. Okay, maybe if there's no question for now, I have one question that I wanted to pose to all the panelists, and that is, where do you see the opportunity specifically to collaborate with German companies or the German space sector? Where are the intersections of the Israelis and the Germans?
I will start.
Thank you.
From our perspective, we're looking into partnership on the industrial of manufacturing electronic boards that are qualified for space that we are looking for now at Cielo.
So I'll jump in. We're looking for partners that will integrate our technology. I mean, we're always looking for manufacturing partners, but we're looking for companies that want to integrate our technology into their products. Because we own 100% of our hardware, software, and optics, we're able to very easily customize things for specific industries and companies for their specific needs.
Okay, thanks. As I can see no further questions in the chat, you will also have the opportunity to pose questions afterwards. As I mentioned in the opening remarks, that we are very happy to make introductions between the German and the Israeli companies. And we are always open to assist you with any assistance that we can offer you. So I want to thank all the panelists for their great presentations today. For all the attendees, thank you for being here. You will have the opportunity also to rewatch this session as it has been recorded. We will forward you it via email. And yeah, this was just a kickoff to hopefully a great follow-up event soon. And yeah, thank you and see you next time.
Thank you.
Thank you all.
Thank you very much.
Thanks all.
Bye. Thank you very much.
Thank you.
Thank you.
Tal?
Yeah,
Can you
we
stay?
start.
Can you stay with me and Jonathan? Nofar, you're also welcome.
Yeah, we'll stay.
Okay, yeah, there's still 2 people in the audience.
I see there are still 4 more people in the call, right?
I see us 4 and 2 attendees. No.
I'll send you a new link in a minute, okay? Tal, let's just
Yes.
Cool. Okay, so let's close this one and we will jump on another one. Thanks.